Right, welcome to the assembly video of the 5HP24. Wanted to do this earlier but didn't have time. This is basically the housing and this is the guts of the housing. You're not looking at the pump and the tailpiece here because I'm going to do them in a separate movie. Maybe paste it behind this movie. You've got the new clutches over here and I've got seals out of camera reach over there, a seal kit. What I'm going to do in this video is take everything apart, inspect everything, put everything back together. Before we start, this gearbox, like all those other automatics, is full of needle bearings, and if a needle bearing is in okay shape with absolutely no scoring, pitting, and it sounds nice, I mean it sounds like rollers in oil, I always reuse every needle bearing. On this transmission, however, I really take a close look at the input drum needle bearings because they are known to go bad on four-wheel drive versions, and I don't know specifically why four-wheel drive versions. It could have to do something with like feedback load they get, I don't know, but even on these rear-wheel drive versions, I make sure I check those input drum pack bearings. Alright, so I've got new clutches here. This is Allomatic. The brands that I like to use for the Gearbox are ZF themselves, Allomatic, the other American, Transstar or Transtech, and maybe Exidy if you cannot get the rest. There is also a brand called Lintex. I think this is Chinese. They're pretty affordable. I haven't used them yet. I can't guarantee that it's actually a good brand. I think my next build I may actually use Lintex, then use the box myself just to check it out, what those Chinese guys can do. First thing we're going to do with these clutches is we're going to dump them in this cut open box full of ATF, so that my clutches are being soaked full with ATF, because that's what we like to see when we do a new rebuild. That's also the ATF where I'll lubricate the bearings in. And we're going to start with this output set. Right, so the output kit has the downside of all those Torx bolts. I stripped a few, I'm going to need to get new ones, but I've got 3 that will hold it together. First thing we're going to do is put it on the side like this. We're going to pull that gear set out like this. There's nothing to see here. You want to inspect your shaft for spline damage, but these gearboxes are known for spline damage. You want to inspect the shaft itself for any wear, burn marks, scorch marks. There's a little bit of dirt, so let me just get a rag and clean it. Then we want to look inside. We want these gears to run nicely and we want them to stop quickly, so we know that their bearing play is okay. We want to take a gear, we want to wiggle a bit. We don't want to feel any sleeve bearing play. Usually you do not feel that on these gearboxes, they have solid gear sets. Then we want to go with our finger on the needle bearing here, because the only way you can actually check the needle bearing is if you take the entire piece apart. But then you need to like spot weld it back in, so we're not going to do that. And when you use your finger, you want the needle bearing to be absolutely quiet. Maybe you hear a little bit of oil washing sound of those rollers running in oil. I'm going to put this close to the camera. Not a sound. That means we've got all our rollers and we don't have any pitting or scorching on the upper or lower race. So we're going to go ahead and reuse this needle bearing and we don't have to do anything about this gear set. We're going to put the gear set aside. We're going to take the actual drum. This is where our one-way bearing is at. You can see that I can turn the gear clockwise, but it blocks counterclockwise. So just keep that in mind in case you take this apart. We're going to need snap ring pliers. We're going to have to remove a snap ring here. It's a pretty loose fit, so I think my fingers will be enough. Let's put that to the test. There we go, snap rings out. And with the snap ring we can pull the entire bearing out. We want to make sure, we want to turn this around, inspect this a little bit. Well, we have a little bit of, I think this is machining that we're looking at, so that's not a problem. We want to spin this bearing and we also want this bearing to spin nicely. And as long as that bearing spins nicely, just like with the needle bearing, let me put it close. No sound. We don't want to do anything about this bearing and we want to keep it intact. We do not want to remove the snap ring and I don't even want to inspect it. I see no debris, I see no dirt. I have no reason to assume that this bearing is bad. If you really want to do this thorough, then you should take it apart. But in my experience with the 5HP24s, and I've done a few, you're not going to have trouble with these rollers. I know that the GM4L longitudinal gearboxes are actually known for blowing sprag bearings, but the ZF box is not known for blowing sprag bearings. Next interesting part is our drum over here. First we want to check that this bearing on the inside is smooth, and you're actually going to hear this bearing because it has these long needles. But as long as it runs smooth like this, it's going to do fine. Now we want to turn it around and check any bore wear. There's nothing we can do about bore wear, but we're not going to see that here, so that's good. Now we actually want to take, let me see, my screwdriver, and we're going to take that snap ring out. And then we're going to count plates. So we have the entire clutch back here. Let's count 1, 2, 3, 4, 5, 6 clutches. That's normal. Double wave plate. That's funny. You see the thick end plate here. It's used to hold the entire pack in the drum. Else, if this was a thin plate, it would bulge out. You see a wave plate here for smooth engagement. Then you see clutch, steel, clutch, steel, clutch, steel, clutch, steel, clutch, steel. That's normal. Clutch, steel on a thin steel plate with another wave plate, and that's actually funny. This one has double wave plate, but I guess CF had a reason to do this. Okay, I got my cup spring out, I've got my drum back, I put the clutch back in. I forgot to mention that this is a nasty clutch to set up. The end play of this clutch, ZF original, is like, according to the manual, it's like 2.3 to like almost 3 millimeter, and that's a lot, even for like a reverse clutch. But I guess with 6 plates it's pretty normal that they put that high of a number in. It happened to me before on a gearbox rebuild where I needed to use a thinner snap ring, even though the clutch plates were identical to the new ones and just as thick. There was no wear on that clutch, and I think I'm going to have the same here because I showed you how good those clutch plates are. So I'm going to make sure, since I know that this gearbox worked, I want to measure the end clearance that I have right now, and I want to use that as a minimum. I want to achieve that with my new pack. Let me see. No, 1.95 doesn't fit, 1.9 fit. So we're going to put this on 1.9 with the new parts. Let's take it apart. This is the old piston that I'm going to talk about, and this is the old clutch pack. I've got the new pack oiled up and ready. So here's the old piston. I want to talk about this piston, but what happens on these molded rubber pistons is that the vulcanized rubber lets go. You get a piston leak, and so your clutch doesn't engage properly, and in this case you lose reverse. All of these boxes sooner or later will get it with the molded rubber piston design, but I guess fluid condition, overheating, yes or no, debris in fluid, I guess that influences if your piston is going bad or not. So I'm going to put that old piston away. I've got the new piston here, and as you can see I ordered an ADF already. Brand new piston, going to put that in, and you want to put it in gently, and then you want to push it with 2 fingers, and you will hear it pop. That was the pop. Now I'm going to put my retainer back in, my cup spring with retainers, and I'll be right back. So I got my cup spring back in with the retainers. I now want to rebuild my clutch with new clutch material. I see no heat marks on the steels. No burn marks, nothing, so that's pretty okay. I'm gonna reuse them. And now I actually need my new clutch material, so let me get my old material out of here. Let me get the new ones out. Everything's okay too. So there we go. Now I'm going to put back. There we go. Snap ring nice in position. The opening of the snap ring nice in one of these open teeth. And the final part is going to be checking that end clearance. Remember that we had that 1.9. So we want to approach 1.9 again. 1.9 goes in, so that's good. Let's see if it goes in on the other side as well, just to make sure. Yep, that's 1.9 again. I had to use a little bit of force on the first measurement as well with the old pack, so this is going to be alright. Yep, 1.9 goes in. Another one. Okay, so that's pretty okay. That's a new clutch pack with a new piston at about exactly the same play that it had before. Before we continue with this, I want to use my finger, and I want this bearing to be pre-lubricated. See it? There's only one way you can fit this, else your bolts are not going to line up. You see 2 isolated bolts are over here, and they go on the bottom. And when that happens, you will have your let me see where it is, your feed hole also in the right direction, and you will have this groove here in the right direction. So with the feed hole pointing upwards, because my gearbox is also with its bottom upwards, I'm going to slide this in as smooth as I can. And I can feel it's going into its bore now. So it's going to be a pretty tight fit. Let me see how we're lined up. We need to twist it a little bit. That should be better. There we go. Let's see how we're lining up. Oh, that's actually perfect. So now I want to wiggle it in. There we go. There we go. That's it. Let me see. Yeah, you guys can see it. You will now see through your bolt holes that your thread is becoming visible. And I want to secure it with, let's say, 3 of these guys now. Okay, that's it. So we are ready for the second part. I'm going to put the gearbox over here so we have some room. I'm going to put that seal away, that old seal. I'm going to put these guys away. Let's see, second part that we're gonna do is actually this big gear set, and let me assemble the gear set the way it is. You will have disassembled it this way, so you have a shaft through a gear set to another shaft, and we actually have our output shaft right here. This gear set doesn't have clutches, so this is just visual inspection. Let's pull it out. Alright, first thing we gotta inspect. On this output shaft, we want these gears to feel nice. Yes, they do. We have no play on them. They all spin nice, no sound, so that means sleeve bearings are okay. You can really check it like this. Sleeve bearings are okay. Now we want to check the needle bearing. I don't feel any resistance, so it's not running in grooves. Let's see if you can hear it. I don't think you can hear anything because it's actually really okay. Want to take a quick look inside. This is very difficult because you're not going to see anything actually. Alright, so we're going to drop some lube on this. Just ATF. There we go. We're going to put that gear set away for now because we're not going to need it. Now we've got this big set. There's a snap ring right here. Let's see, it has an opening. There's my opening. Snap ring comes out. Then this gear can come out already. That gear is gonna come out. The ring. Okay, ring is out. Let's see, this planet is coming out. Right, here we got another inspection to do. You see that in this set we also have gears. One's fine, second's fine, third's fine. Fourth's fine. Let's see if we have any play. No, no, no. Then we've got a needle bearing. How does it feel? Can you hear it? I can, so that's good. On the other side we have a needle bearing that we can take out. So we want to take that out so we can really inspect it the way we should. We want to see that the needles are intact. So here you see intact needles all around. And then you want to see that it runs nicely. And if you would see cut grooves in here or scratches on the inside of the race, those are reasons to renew one of these Torrington bearings. So this one we lubricate by dripping it. That's actually very convenient. That one we lubricate by hand. If you have like this transmission assembly lube, you could lube it, I guess. So we're going to put this guy away. This guy's ready. Now we see another snap ring in the drum. And we're going to take that snap ring out. Those are actually the same snap rings because it's like the same diameter. And we're pulling another ring with a gear set out. That means we're pulling another sun gear out. Here we have another needle bearing. Good shape. And don't be Surprise, this is actually double, because you see double races here. And you see that both can move, so you really want to verify that the entire needle pack here runs smooth like it does. See? We got to check some gears. 1, 2, 3. No play, nothing. Time to lubricate this piece. There's not much to see here. You could check for like gear wear, but you're not going to see that on a 5HP24 unless it's seen a very bad life. And we are now able actually to reconstruct the entire gear set. We have an O-ring, but we can also replace this later. We do not have to replace this now, so that our teeth cannot cut the new O-ring. We're going to drop him in. See if you are coming through nicely. Yes, you are. Then we can put that snap ring back in, and I'm going to have to put him on the side, else my gear set jumps out. Putting the snap ring back in. Snap ring sits, so this guy can come up the way it should be positioned. Right here we have a gear. This gear can be put in both ways, it doesn't really matter, but if you see the cut over here, you will also see that the cut is down there at those gears as well, and that's how you know that you got to put it in that way. So gears in that way. Let's see, snap ring was in, so we're gonna put let's see, this guy in. Oh wait, before I forget, actually, we also have a bronze bushing here, because there's another shaft that sticks into this one, and we got to inspect the bronze bushing. I have a bushing kit, but I don't often use them, because most 5HP24s that have been taken care of do not have any bushing issues. That's not scoring, that's just dirt. Let me show you, let me see if, hoping that you can see the surface. Looks okay, it's not like a faded surface like you'd see on worn engine bearings. So we're going to use that again. Okay, so let's put them in. And now we gotta play with him a little bit. There we go, that guy's in. And on that guy we will have our ring gear, oh sorry, sun gear that can only go in one way. There you go. Then we had this big wheel that can go only in one way. There we go. Then we had another snap ring. And these are just, these are not really snap rings like clutches, these are just retaining rings. So in this case it doesn't matter if my ring is actually in one of the teeth. There we go, snap rings in, this guy's in. We already checked him, so we fit him now. There we go, pack's ready. We want to put this pack into the gearbox, and now we will need to put the gearbox down again, because what you'll see now is that my shaft is going to stick out, so I cannot put the gearbox on its back anymore. Let's take this O-ring out, and let's put the new O-ring on. O-ring is on, old O-ring away, don't want to mix that up. And now we're going to carry this entire pack and we're going to put it in. Yes, you guys have got an angle on this. And we're going to put our hand through that gearbox where you have the valve body normally. And we're carefully going to slide that output shaft through that bearing. It's that bearing with that retainer ring that I pointed out earlier in the video. And we're going to guide with my hand right here. I can already feel the output shaft coming through, so I can guide it in. And now we want to guide this through so that that gear thing that sticks out with the roller clutch needs to grab into this drum. Right. So if you have done this correctly, you will see that this big steel auto drum is just barely clear of that next drum, and you want to see that the geared wheel that's on your roller clutch is in the drum right here. It will go inside the drum. We're gonna do the carrier. Oh, sorry, the center support. thing about that center support is this is basically the deciding part how powerful your gearbox is. If you have a weak version like the Jaguar 3.2 version, you will have less clutches and steels in this drum. If you have the strong version, that's the 4 liter or 4.4 liter, you have one more plate in this drum, and the strongest version, the 4.6 version, even has 2 more plates in this drum. So that's interesting about that drum. You cannot really go wrong with this drum. It can only fit in one way because you need these feed holes to point here to the valve body. You've got these 2 keys that hold it in place for the center support. That's basically it. And it goes in like this. You have this disc here with the bearing, and that disc sits over there on the part right over here. Okay, so let's get started. We're gonna put that disc with a needle bearing that you see right here, and which we can immediately inspect. We're going to put that away for now. You can actually see how the needle bearing ran, and now you can see when I clean this with my finger, it's a bit polished where the bearing ran. That's fine, but there's no scratching, there's no pitting, and you also see that I have all my needles and that everything is intact. So when I was looking at those gear sets, this is what was happening in the gear set, and as long as you don't hear anything, you know that they're running over a good surface. This we can already lubricate. That bearing we can already lubricate, so that's good. And we're gonna put that bearing and this drum aside for now. Yeah, we can just drop out the shaft with the other drum that you see right here. Rule of thumb here is that you need 0.38 millimeter per friction disc, and since I have 1, 2, 3, 4 friction discs, that's about a 140 or more. 1.5 fits. 1.5 fits here too. So we're going to leave that at 1.5. Keep in mind, 1.5. Alright, it's time for the fish are snap ring out. Snap ring is out. Time to unstack this set. Friction actually looks really good. And this is a really working clutch. This is not just a silly reverse clutch. Steels look really good. Very nice steels. No burn marks, nothing. As if these clutches haven't gotten anywhere at all. That's pretty amazing. Drum itself looks okay too. Now again, I'm going to take my press, I'm going to compress this, I'm going to take out the retaining rings, and I'm going to take out the cup spring. So I'll be right back. So there comes my cup spring. This is one of those pistons that we need to push out by air. So there we go. This is a full steel piston. There is no issues with these steel pistons. They basically last forever, unless of course you have strange wear damage. And let me see. This one has an O-ring right here in the middle that we need to replace. And it does not have an O-ring on the outside. The O-ring on the outside is actually here in the chamber. So we want to take both of those O-rings out. O-ring number 1. O-ring number 2. There we go. Inner O-ring first, lubing it with ATF. Groove has been cleaned. I put a towel through. I'm not going to clean this drum anymore because, as you can see, it's already in very good clean shape. And now we want to check that we didn't put a corkscrew in this O-ring. No, we did not. Now we take that inner O-ring, and now we're going to push this steel. Let me see if there's an O-ring here. No, there's just a retaining groove. Now we're going to push it in, and we just want to hit click. There you go. And once we reconstruct the clutch pack, we're going to test it with air, and that's how we see that we're going to hold the seal. I'll be right back because I'm going to put the cup spring and the retainers back. Okay, so I've got my cup spring back in nice. Gonna need 4 big size clutches, so let me get this out. And we've got our thicker end plate. Gonna put the old clutches away. Let's put the snap ring back in, and let's check what kind of end play we have. 1.35 goes in again. Let's continue and let's put all these snap rings away. The other side, well, that's not really that much difference. We're just going to take that snap ring out. we're going to destack that clutch. Here we are. This does have a wave plate. Oh, this one has a bad. This one has steels that I want to reconsider. I'm going to show you. This is the wave plate. Wave plate is always extremely dirty, so let's ignore that wave plate for now. Here you see the first steel, also a bit dirty from the wave plate. Now you look at the other side. This is burn marks. You want to buff this up, and if they're still flat, and you can see that with your eye, you don't need like a straight edge or something, you can see that it's still flat, that means it's usable. If this wasn't flat, you definitely have to renew it. Here you see the clutch. The clutch itself is actually not that bad at all. You don't see any burn marks on the clutch. What would happen is you could see like light clutch material here and dark clutch material over there, and that means that the clutch has been dealing with temperature, but that's pretty alright. Here you see another steel that I need to buff up, or just take other steels because I've got plenty of reserve. Another fine clutch, another burnt steel. So this has seen some wear on the steels, but I wouldn't be too worried about it. Okay, so with the pack out, we need to get this cup spring out. And here's the funny part: this cup spring actually has a snap ring here. So either you need a very strong but also thin snap ring tool, or you just compress the cup spring and then take out the snap ring easily. I'm going to compress it and I'll be right back. Okay, so my drum's back, got my cup spring and my snap ring here. Yeah, I got a press and I've got all kinds of pieces to help me with this, and you guys probably don't. So another idea is that when you have this cup spring in and you have that snap ring in like this, you take a screwdriver and you enter right here from one of the open teeth areas, and you just wiggle it out of its groove. Because if you don't have a big ring like I do, it's difficult to compress the snap ring. Once the snap ring is compressed, I mean the cup spring is compressed, snap ring comes out easy. So you kind of have to find your way in how to get this ring out. Getting this piston out the same as before, we're gonna need some air. Now it's coming out on one side and it always stays on the other, so I'm gently gonna use my flathead to help it a little bit. There we go. And you don't want to do this in the O-ring groove, you just want to do this on the dead material of the piston. There you go, piston coming out. Here's our piston. You see another very nice and clean drum with like a little bit of goldish oil. This piston has 2 O-rings, there's nothing else to it, so we're going to take those O-rings off. That's a big one. There we go, inner O-ring is in. Now we're just gonna go ahead and push this down, see if we have anything we want to clean. No. There you go, you heard it pop. Now we want our, hang on, let me put those old O-rings at the old seal pile. There we have our ring, and now we want to put our snap ring back in. And I should be able to kind of do this by hand. Go, that should be about it. Took me a while, a few minutes or so. There we go. Nice, yes. Just want to make sure I clean everything. Alright, so I've got that ring that I could have used but I didn't. I put the snap ring on. With a big screwdriver I push down so that the snap ring grabs over the cup spring and in the groove. And by going around like this per 2 centimeters, you are able to push it in. So you push down with your fingers, you pull the snap ring in. You really need to push down hard so you compress the cup spring, and that's another way with rudimentary tools how to get it in. Let's see. So with that piston done, with that snap ring back in place, let me use my finger to clean the surface. Let's see. Before we assemble it, we gotta take a look at that needle bearing. Let's not forget, we are ready to rebuild the clutch itself, and this is a clutch with 1, 2, 3 plates. 1, 2, 3. Is that right? Yes, that's right. Okay. And this is where I had to buff up those steels a bit. So I'm just gonna, let's see. We can put that wave plate in already. So we got that taken care of. With like 10 seconds of Scotch Brighting, you can see that my burn marks are fading away, because this is a fresh mark. This is the Scotch Brighted mark. And that's how you want to buff up the whole area. And then you want to clean it. So I'm going to be buffing up those steels and I'll be back. Okay, so I buffed them up a little. You see that the burn marks are disappearing. I mean, the more you start rubbing and sanding at them, the more they disappear, but you're also thinning out your clutch plate. You can see that the surface, let me see if you guys can see, has now become a bit more rough compared to a glazed steel plate, and that's actually useful because that actually means that the friction is going to be a bit better. On your pack you can compare this by taking the thick end plate, which is this one, and on one side of the thick end plate you will never have to do anything because it's the side that's on top and it doesn't wear, so you feel a certain smoothness. Then you go to the side that you've been sanding and you should feel that it's a bit rougher. And that's actually going to help engaging. Now we got to think about what we're doing because we have a middle plate here. You can see that we have an end plate and then 1, 2, 3. And we want to use the most damaged, or let's say the most burned plate, which is this one, on the bottom. And then we want to use the 2 least hit plates, because that's where all the heat is going to be. So this is how we want to construct that clutch pack, and that will actually, I wouldn't say guarantee, but that's the best way of approaching this situation. Now let's put that snap ring in. Snap ring in, 1.05 fits. Let's put the boundary at 1.4. 1.4 doesn't fit. That's how we're going to do it. Okay, here's our setup. This allows us to drop the drum in. Remember, we had this steel part already in. Let me take it out. That O-ring that we have on the drum right here that you'll see will now seal on this steel part. So we're going to put that in. So we're going to put that bearing plate in. And we want that bearing to be ready also. We put the bearing in. That's tricky because the moment I put the drum in with the bearing is properly guided, but I risk losing the bearing. So that's always a trade-off. We're going to put the bearing right here in the middle where it should sit. Bushing is still okay. No marks or whatever. Let me put some oil on that bushing because it's going to grab on the shaft right now. Okay, now we want to drop this guy in, and it's going to be stuck with these keys, but there's no way we can get the keys in later. And we want to drop it in this way so that our feed holes are lining up right over here. And then you'll see that the keys can only go in one way. So I'm just going to drop this manually. I don't want to use a hammer for this because I really want to make sure that I'm not putting too much force on it. And there's no other way to do this, because the moment you do this without keys, it's going to fit real easy, but you're not going to get those keys in anymore. Alright, and now I want to make sure that she doesn't fall out of my hands. So I'm just going to put a screwdriver in, so if she drops, she cannot drop on bearings or on the drum. And she's going to drop on the screwdriver. There we go, she just dropped on the screwdriver, so I can put that out now. Pretty okay. Now I'm going to put the screwdriver on that geared surface, just as an extra measure. Deeper. There we go, that was it. And now we're going to reach the point where everything grabs into each other, and where we need to make sure with this long screwdriver that the needle bearing sits in the middle, which we just did. And we can see that the feed holes are going to line up. There we go. So with one hand I am pulling on the plates so that the entire drum moves upward. With the other hand I am turning at that drum, that's at that light metal drum on top of this carrier. And you will see millimeter by millimeter that she's dropping in. When another clutch grabs, she drops in. There we go, another millimeter. You may need some patience, and we can see right here, if the holes line up, we know she's in position, then we can also see that the bearing is in position. And that's correct, because I see my big snap ring groove appearing. I'm just going to continue, pause the video, and cut right to the moment where I have it flush. Okay, I got it lined up. I'm not sure if you can see this, but I can stick a screwdriver in, and these feed holes are centered. Let's see, this guy's centered. I checked it out on the inside, the bearing is good. And now what you're going to do is you take that big snap ring, and you're going to put that big snap ring in just like that. Another indication that you're doing the right thing is if this big thick retaining ring is really nice in the groove, because that means your drum is sitting nicely. Then you're all set. Before we're going to start on the next drum, we're first going to round up some stuff on the inside. I've got the center support and I've got the holes lined up. So I can now put this pipe back right here under to the right of these two, looking from the back. And I'm just going to push that in. This is like a double clamp that sits right over here. So on the other side of this is selector, it sits on the other side of the selector, and you must have disassembled this when you were doing the disassembly. And we should now be ready to fit that back. Let me just check out if this pipe is really grabbing properly. Well, yes it is. No other way this is going to go in. So that's good. We will torque that down the moment we're really done with the gearbox and are closing in on the valve body. These are my two sensor retainers. I do not need those now, so let me put those away. Okay, we can also slot in those rings that we had here. You had like these little rubbers that you put in these holes, so we're gonna put those back in. Now they had springs on them, so that's two identical springs. You cannot mess this up. And those springs are being held with these little clips, and you got to be careful, because if you use force on this a little bit too much, that clip is going to jump away from you. Ask me how I know. Never mind, I'm going to take pliers just to be sure I don't screw up. Sometimes I can get them in by hand, this time I cannot, so let's take out the pliers. There we go. Nicely deep inside. Gonna let go of them. Gonna hold my thumb on it in case it pops out. It doesn't pop out. Let me use a flathead to push it back in. There we go. Both are at about the same depth, so that's definitely something. Okay, so those are in. We got the next drum coming up. I've got the needle bearing for that already here. This is a drum with an intermediate shaft in it. Let's first measure that clearance on both sides. I guess if I kind of, well, 1.6, 1.65. If I kind of force it, I would probably get it in. But we're not supposed to do that. I promised you I'd put the gearbox away a bit, so we have some more room here. Let's take that snap ring off and disassemble this this drum. Let's take the entire pack out. Got another wave ring. What does our pack look like? Pretty okay. Very good friction. Excellent steels, no marks. So basically we only had one pack where we had marks. This pack is absolutely clear. Absolutely clear. This is good. Super steels. I'm gonna show you. This is like, I wouldn't say new, but this is really really in good shape. We want to pull that shaft out. There we go. Here you see the shaft, two O-rings and two piston rings. We're going to put that away. No, never mind. Let's inspect the bushings while we're at it. This one has two bushings. I want to take a look at them and then I'll show you. They are in good shape. That's in pretty good shape. Alright, well, this process is well known. This is just gonna get that cup spring out. I'll be right back. Cup spring and both retaining rings are out. Let's see. I'm gonna need air for this, and I'm gonna have to put that air right there. There we go. You saw how I did it. I put like a rag all the way here to block all three holes. Then with the compressor, with the pistol, I put air on one of the holes, and that's how you get that piston out. No surprise so far is that again we have a very nice looking drum on the inside, absolutely clean, and this really is the piston coming out genuinely. No trickery here. So we're not gonna argue about this a lot. We're just gonna go take those O-rings off. There we go. Yeah, we're just gonna, let me check it once more. There we go. Let me see. Cup spring back in. I want to reposition the camera a little bit. There we go. Okay, we're gonna stack that. We're gonna stack that clutch again. Let me get out the new plates. I need 1, 2, 3, 4 plates. No. There we go. Okay, according to the book, we need 1.35 to 1.6. Yes, 135 fits. Luckily, we don't have to do anything here about snap rings, so that's good. Careful, I don't want to use screwdrivers on this. I just want to use my fingers so I feel what I'm doing. There you go. You will sit right in. See if I got corkscrews. No, I don't. Piston ring number 1. Piston ring number 2. You can feel the difference. These piston rings are really still open. The old ones would probably still work. It's not that they're not going to work, but you will definitely feel that the new ones over here are a bit wider. Alright, I've got one opening of the piston rings here, I've got one opening of the piston rings there, and that's how I like to do it. There we go, and now we just want to shove this over the previous one, but do not forget that the previous one still has a bearing that we almost forgot about. And that bearing actually sits over here. So with the bearing right here running over our shaft, we want to fit this in. See that the bearing has only one race because it runs on the drum. I said shaft, but I meant it runs on the drum. There we go. I can't go any further. And I see it's taking clutch material with it. Okay, that's good. I'm gonna put you guys aside. We are now approaching the final part of the housing. I mean, we still got a pump to do. And you see that we are now gonna work on what I call the front or the forward pack. You remember how we took this pack apart, just like the way you see it here, and we're now going to split it into multiple drums. The dreaded A drum is part of this. This A drum is okay, I know that for sure because I found no debris at all, and the rest of the gearbox is really in top shape actually for its age. So let's go ahead and remove that snap ring and disassemble this forward pack and see what we find. Big snap ring. This disc comes out. It has a sleeve bearing in. So far it looks okay, but let's look at that later. And now we're just gonna pull this drum out. And it has a needle bearing right here that we don't want to forget about, and it has a needle bearing on top. It's one of those dreaded input drum bearings, and that needle bearing runs right there on the drum, so we want to keep this together. This doesn't have any clutch material either, so we can just park it over there. Take this small drum out, nothing special here. Another needle bearing that runs on the drum, we're gonna put that away. Here's our dreaded A drum. Yeah, well, what you basically do is you take the drum like this. Remember, there's also a needle bearing right here. Let's just put that away, and you just tap on the outer drum until the A drum comes out. Let's see if I can do this with only a few taps. There you go. And it looks like it hurts, but it doesn't. You don't even need to tap it that hard. So here's our dreaded A drum. And this is your input shaft where your converter sits. This is your forward clutch that you need for your first, I think it's first 4 gears. And then in the 5th gear you no longer need this drum. So fail-safe mode, which is I think the 4th gear, also doesn't work on this transmission when you blow this drum. And there's many movies about it, so I'm not going to go into detail, but because of wear in the valve body, all of the drums are receiving much more pressure, and this drum is the first guy that dies from that high pressure. What happens is the pressure pushes the clutch against the snap ring here, and the snap ring will then push right here on the edge of the drum as it's supposed to, but with too much pressure it will actually break that edge of the drum, and the clutch will free float and it will no longer grab, and so you no longer have forward. It's not really that difficult actually. Not going into detail about this, I'll do that in the valve body video, but you can see that this drum is still intact, and I'm really checking for wear here, but there is no wear, there are no cracks. Did I say that correctly? Yes, I did. There is really no wear here. So we're just going to go ahead and rebuild this. I'll do the big one first. And that's it. Since this drum isn't cracked, my valve body bore is still in okay shape. So a Transgo kit is probably going to make this valve body last long. I have good experience with the Transgo kits, but if you don't like it and you want a new valve body, go right ahead and get a new valve body. So we'll take this big guy over here. As before, let's take pre-measurement. 2.45 millimeter, still fits. Okay. What about this side? Preferably wanted to fit on both sides. 2.45. Okay, so dismantling as we have been doing so far. Snap ring. Get out of here. Unstack the entire clutch. There we go. See what we're looking at. Wave plate, steel, clutch, steel. Steel's in good shape, clutch is in good shape. This is another good clutch. Let me show you. You see the steels, you see no marks. You see clutch material with friction left, good friction left. So that's an okay pack. I'm gonna compress the guy, I'm gonna get the snap ring out, and then I'm gonna release the cup spring. Yep, that's how we're gonna do this. Alright, I'll be right back. Okay, so I got the cup spring out with the ring and the clip that holds the ring in place. A bit different design here. Now I just need to put some air on one of those feed holes. That's it. Piston is out. Okay, 2 piston rings and an inner ring. See about that drum. Nothing to see here. Yet again, very nice clean drum. No issue over there. There we go, ready to install. See if there's any specific way they want this installed. No, it doesn't seem to be that way. Let's drop it in. Want to hear that click again. Click. That's it. Alright, we're gonna put this under the press. All around. Snap ring is okay, check it out. Rings in position. There we go. Okay, manual says 1.95, 2.25. 1.95 fits, so that's good, because the 2.3, no way we could get it in, and it said 2.25 in the manual as a upper boundary, so that's good. This drum's ready, we're gonna put that away for now. Okay, final drum and clutch pack to do is the actual dreaded A drum. You see that I've got 3 A drums. This is the one from the box that we're doing. This is a spare one that I have that was still intact, and this is another spare one that I have that was still intact. These are from boxes that are broke for parts. Could be any kind of damage that gets me that box cheap to take it apart, and if I see the A drums are intact, I save them. They are still available new and also from reputable aftermarket brands, but there is going to be a time, let's say in about 5 to 10 years, where it's going to be more difficult to get those A drums because of the transmissions no longer being viable for companies to produce. So let's just do this methodologically. I want to measure the end play that I have, and on this drum the problem is that the final steel ring, which I have another one right here, has this incline, and so I cannot use feeler gauges properly to measure. But we got a workaround for this, because we're just going to put the feeler gauges between the first clutch plate and that final steel plate. I'll show you what I'm talking about. Let me take out a millimeter. I'm just going to put my feeler gauge right there, and this will also allow me to measure the end clearance properly. So according to the book we need 1.95, 2.25, and that's realistic because we've got 6 discs. No, 1.8, no way I'm gonna fit 1.8, absolutely no way. So this A clutch, although properly done with steels, frictions, whatnot, is definitely not within spec. This is way too tight, and I can also feel it when I'm moving this A clutch, that it's too tight. I've got another A drum right here, still with the clutch intact, and I can feel it's a lot looser, and this one actually is within spec. So let's take the screwdriver, let's take it apart and see what we get. Okay, as expected, we have a wave plate, we have steels, friction, steels, and I have we've got burn marks on the steels, and we've got marks on the clutches as well. Let me show you. Clear burn marks on the steels, actually more than we've seen before in the transmission. Now let me show you a clutch pack. Let me clean it. This is a clutch pack after I clean it a bit with a rag. You can see right here that you have like a brown new looking surface on the outside, and you have a black burned surface on the inside. And this is not like totally burned, so this gearbox probably still worked, but this is how clutches are going out. And I don't know how this gearbox was used because I never saw the car that this gearbox was in. It definitely worked because the pack is okay and the drum is okay, so this was still clutching and grabbing and holding. But I think because of the tight clearance, this clutch was dragging a little bit and was slowly wearing out as it was shifting and producing too much heat, and that would also account for all the burn marks. Let's take a look at that other A-drum that I have. Since this is the dreaded A-drum with so many stories, I don't think it really hurts if I expand the video a little bit and show you another A-drum that was running on proper clearance. Wave plate with a clutch pack, same deal. Alright, see, right off the bat you see clean steels. These steels are okay, no burn marks. You also see that the clutch material does not have that double colored stuff. This is still good clutch material. So that's basically, this is basically a consequence of setting your clutches too tight, that they drag. I really think this is it, because the A-drum is known for braking, but the A-drum is not known for burning its clutch if it isn't broken. It's a pretty reliable transmission aside from the braking. So the only reason I can think of that clutch being in that burnt shape or semi-burnt shape is that it was dragging because of low clearance. Let's talk about the A-drum. Here I have an empty A-drum just to show you what we're talking about. This is the drum that everybody talks about on the internet. Basically the pressure in your valve body increases up to the level where it pushes against the snap ring here right through the drum, and so the clutch goes free into the open area right there, and it doesn't clutch or grab anymore. So that's why these drums fail. This is an original drum. These are already the updated model with dimples. So that's also how I know that somebody has been here before. Also, you see that this final ring of the A clutch has like wear over here. What probably happened is that the original A drum in this transmission broke. So that this was pushed out and this was running into the surface of the next drum, and that's why you have that funny looking damage over here. Because if we take this other steel that was in the drum that was still that was in my separate drum, you see that it's completely smooth surface. So we're going to use this one because there's no thickness, there's no difference in thickness. We're going to use this one because it's totally clean, and we are going to reuse the drum because the drum is fine, and because I'm going to update that. I'm going to update that valve body with a Transco kit. So it's not going to break anymore. To get this piston out, you need to compress the piston, and then you need to get that spring ring out, that retainer, and then your piston will come out, and you can inspect everything under the piston and put new rings on it, and I'll be right back when I've got this out. Okay, so I got the drum empty. You see my clip here, you see my cup spring here, and you see two pistons here. This is like a double piston design, basically. We've got the piston right here, which is the one that you see when you have the drum in your hands, and this is like the bottom piston, which goes first. And this one has an outer seal that I gotta replace, and this one has an outer and inner seal that I gotta replace. Then I push this one back in, then I put my spring back on, then I put my upper piston back on. There's not really much that can go wrong with these pistons. I mean, they're not known to fail. Even though the A-drum is critical, it's because of the snap ring, not necessarily the piston. So I want to get these rings out. Lower piston is ready. Upper piston ready. Let's see, that's only one small O-ring left, so that's good. We're going to put that lower piston back in. Here you see an empty drum. Very good shape. So let's push him in. We want the dimples to point upwards, because this is where our cup spring is going to sit. If we would do this the other way around, that wouldn't work, and you would see that the seal is not in the right position. So there we go, he's in. Cup spring back on, upper piston back on, and we're going to push that upper piston in with the press, and then we're going to put the ring back. So I'll be right back. Okay, here's our drum again. Now we know that we're going to be in trouble with the end clearance. Here's my new clutch material. So we're going to rebuild this. Wave. There we go, clutch is finished. That's good, feels like more distance. I selected my, I got the clutch already, selected my thinnest snap ring, because we had clutch trouble here. We had like way too tight clutch. just to be as accurate as I can, I'm gonna push the piston down because it gives way a bit, and I'm gonna measure all the way to the top of the snap ring groove. That's like 4.32. 4.32. This was 245. So that's 187. That's a little bit tighter than what it should be, only a little bit. But this is definitely a thinner ring from the ring that I used, or that the Gearbox had before. So first let's fit the ring. Now let's feel what my clutch is like. So you can see that it has, yeah, like you can compress the piston a bit. So, and my clutch feels nice and loose. And that definitely was not the case when I had the original pack-in with one of my thicker snap rings, or with the thicker snap ring. Final part of this A-drum before we start rebuilding the entire front wheel drive or front drive pack is 2 piston rings and a seal. Let's do those piston rings first, and that's 2 seated with the opening on the other side. And normally I have to replace this O-ring, but before I replace the O-ring I want to show you guys the trick of fitting this back into drum B, because that's where the O-ring, when this is your first time, you actually risk destroying that O-ring right away. So here I have drum B, and as you remember, our A drum was sitting in drum B like that. So you can see the O-ring right there that will actually sit inside here, and because of this geared surface it is very easy to destroy your O-ring. So what you want to do is you gently want to put your drum in, since you're doing this with hands in your backyard fashion, like that. And now you just want to feel until the teeth engage, and as you can see, just push it down. You already heard it click. That's how simple it is. Now this is of course an old O-ring, but you see my O-ring is still intact. So now I'm going to put the new O-ring on. I'm carefully going to feel until I've got those teeth engaging, which is about now. And now I want to push it in. There you go. Okay, so to get that B drum ready again, hang on. I need my final snap ring also. To get that B drum ready again, I've got A and B right here. I've got all the carriers with bearings right here. And the last important step of the gearbox, after you've already assessed your A drum, is the needle bearings. There is a needle bearing right here that sits on the A drum right there, just like this. That's how it runs. And that needle bearing then runs on the face right here of the carrier. No issue so far. This needle bearing and the needle bearing that's right next here are known to go bad on front wheel and four-wheel drive applications. This is a rear-wheel drive application. I've done a few rear-wheel drive boxes. I've never had issues with these bearings. I always keep a new set of bearings because I want to be prepared for this, because many rebuilders say they go bad, so who am I to say that they're wrong? I've also got a set of used bearings here from a box that I broke for parts. These bearings are still okay. The little one is also okay. But I can't really tell you what you should do. If you feel your needle bearings are super smooth, I mean, listen to it. You're not going to hear anything, same here. If your needle bearings are still super smooth and okay, and you didn't have any noise, and the surface here is okay, and the surface under this bearing is okay too, I have no reason to replace these needle bearings, and I also have no explanation why on forward and four-wheel drive they fail so often. It could have to do something with getting feedback from front-wheel drive, from some kind of shaft, or from four-wheel drive, I don't know. But in this case I just checked out the bearings. I'm going to reuse them because I have no reason to renew them. So let me lube them excessively in ATF and let me reconstruct the entire drum pack. So we take the carrier out now. I'm going to put that carrier in just so you see what this should be like. There we go. And the next needle bearing that we now fit is the cup right here. So the needles are engaging right there. So let's go ahead. There we go. Gotta fit this guy, and it's with the sleeve bearing. We want those notches here in the openings. There's, I think, 3 notches, and so there's 3 openings. There we go. Fits. Shaft is nice in place. Means we've got the bearings all right. Snap ring in so it doesn't fall apart anymore. Now this snap ring doesn't have any clutch function. It just holds the pack together. No issue there. Okay, that's good. Okay, the entire pack is now solid. I'm gonna clean up and reposition the camera, and we're gonna fit this pack, because that's all we've got left now before we get to the oil pump. Okay, with our front pack containing the B and the A clutch and some carriers, we now want to verify the final needle bearing that we will not be able to see anymore, which is this one. But even with this one, there's nothing to see. All the needles are in place. Even if I force it a little bit, I'm not getting any needles out. Feels smooth. No reason to assume there's something wrong with that needle bearing. Alright, so we're going to lubricate that needle bearing. Again, the needles point towards the oil pump, and the cup race goes right onto the next shaft that you see here. So we're going to put it on its cup. Right there. I'm going to pull, twist, pull, twist, pull, twist. Yes, that's it. That's one clutch that I saw going in. I need about this much more. That should be about it, I guess. There we go. You now see that my pump sits flush with my house. I still need a gasket here, but that's for the pump job that we're going to do. And you can see my guide pin, which is over here, fits. So now I know that I have my entire drum pack deep enough into the house, properly seated in clutch C. So we, I think it's best if we just secure this so I can put the transmission on the side again, because if I would leave the transmission like this and if it would fall, I'd be in trouble. There we go, this is going to stay in one piece. Alright, this is the result of the movie, basically, of the driveline. Mind you that I need to fit these 2 new rings. So I'm going to put them in my cup of ATF. And these are the 2 old piston rings from the pump. I'm just going to put them over there so I don't forget to take them from the seal kit. Entire driveline has been rebuilt. All clutches are within spec. The only clutch that's a bit under spec is the A drum. It's a little bit tighter than what it should have been. But it's looser than what it was when I disassembled this transmission. As I said before, I said while we're doing the rebuild that I thought this transmission wasn't rebuilt. I think it actually has been rebuilt, and whoever rebuilt it did put the right parts in. I mean, he did assemble a proper transmission, proper functioning transmission, but the end play of the clutches was too tight on multiple clutches. So that's definitely something to keep in mind. The next video is going to be about taking apart and putting the tailpiece back together, end play, and the pump. And with the pump I'll do the final assembly, including the bell house. I hope you enjoyed the movie so far and that it actually helps you rebuild your 5HP 24.